All right, note 7.1, examples of covalent compounds. Well, Lewis structures, sorry. First thing is examples of covalent compounds. We've got, for example, C6H12O6. Okay, no metals in there, right? So that's sugar. As long as there's no metals in there, you've got a covalent compound. CO2, we're breathing it out right now, but in solid form, it's dry ice. HCl, hydrochloric acid, NO2, which is smog. What else? All plastics. All plastics are covalent compounds. Okay, these are nonmetals. All the plastic part of it, at least, are nonmetals bonded together covalently. Okay, the octet rule says that atoms tend to like having 8 valence electrons. Atoms tend to like having 8 valence electrons. Now there's exceptions. Well, this first example is an exception because hydrogen only has 1 valence electron, right? It's group 1, element 1. It's only got 1 valence electron. So let's go ahead and draw the Lewis dot structure for hydrogen. And remember now, there's also there's an empty seat here too, right? There's an empty seat, but it's invisible. So what ends up happening is this electron gravitates toward this empty seat, and that one gravitates toward that empty seat, like I showed you in some other notes, but we don't draw in the empty seats. But what we can do to make things a little bit easier is just imagine these 2 electrons coming together. And once that happens, we end up with, we can substitute that now with a line. That line represents a covalent bond. Okay, and that's H2. And you guys made the model for that. You guys made the model for H2. I'll pause and I'll get you the model right now. So there's the model for H2. Okay, that's the empty seat. All right, this represents the 2 electrons that are bonded to that empty seat. Or the 1 electron from here to over there, and vice versa. Okay, so there's H2. That's what it looks like on the Lewis structure. Looks like of H2 looks like that. If we were to draw the molecular model of H2, it would look something closer to this, doesn't it? Okay, and in the middle there, those are the 2 electrons that are bonded. You don't have to draw that, but the 2 electrons that are shared rather in a covalent bond. Okay, you don't have to draw it. I just wanted to show you what it looked like. Let's go ahead and do another example. Let's do F2. We draw F. The Lewis structure for F is going to look like this. F's got 7 valence electrons. I'm going to make sure that that 7th, the 7th electron is going to be on this side and on this side, just so that I can draw the bond a little bit easier. So watch. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. I just did that so that these bonds are closer to one another. Okay, that's why I drew it that way, and that's acceptable to do that. That's perfectly okay. So there you have those right there. They bond together, and it forms F2 covalently. Okay, and then we can draw in the rest of the electrons. And these guys right here, these pairs are called lone pairs. Lone pairs. Okay. Let's go and do CF4. CF4. Well, carbon is the central atom. 1, 2, 3, and 4. Carbon's the central atom. So I draw that in the middle, and I'm going to draw the F's around it. Now, knowing what you know from the last example, you should be able to figure out then that there's a single atom on one side of the F's, right? 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Now check it out. Look, these single electrons right here are going to bond with that single electron, and that one, and that one, and that one. Okay. And when that happens, we end up with CF4. CF4 looks like that. CF4. There you have that. Again, you could get the model set out and draw that out using one of the halogens. I don't think there's enough halogens in model sets, but not draw them out, but you could put them together, right? And you'd end up with a model that looked something similar to that. Let's do pH 3. Well, let's see where P is. Phosphorus falls in the nitrogens group, group 5. Okay, so let's go and draw that. P, that's 1, 2, 3, 4, and 5. And we know that all the H's have a single electron. Okay. And these guys join. Remember, I'm just joining the single electrons. I don't touch the lone pairs, do I? Lone pairs, you leave them alone. You can't bond anything to those. I can rewrite it as such. I substitute in a covalent bond where I have these two. Okay, do it like that. pH 3. All right, let's try a trickier one. Let's try O2. So oxygen, 1, oops, 2, I shouldn't have done that. 1, 2, 3, 4, 5, and 6. Okay, I should have gone around clockwise, but that's okay. 1, 2, 3, 4, 5, and 6. Okay, cool. You don't touch the lone pairs, but what you can do is these single atoms, right, or single electrons rather, can bond right there. Those single electrons can bond. How many bonds do I have now? Well, I've got 2 covalent bonds. Do you see that? This little bubble right there and that bubble, those form covalent bonds. So I go O with 2 covalent bonds, a double bond, right? And then I've got 2 lone pairs on each. 1, 2, 3, 4. 1, 2, 3, 4. Okay? I draw in my lone pairs, like so. Let's do N2. N2 looks like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. I get 1, 2. Hey, what about this guy over here? They're on opposite sides. Can I bond them? You may think you can't, but the answer is yes, you can. You can bring these together. It's acceptable. You can bring this one around and that one around. I'll just draw the bubble like this. Look. Yeah, those can bond. Those can, in fact, bond, and they do. 1, 2, 3. You've got 3 bonds now. Count them. 1 bubble, 2 bubbles, 3 bubbles, right? So that's a triple bond. By the way, when this forms, this is what causes major explosions. Dynamite, fertilizer, when fertilizer explodes, ammonium nitrate, those types of things. This is what happens. These nitrogens come together and it releases a massive amount of energy. Okay, SBr2. S is in the same group as O. And then you've got Br, which is a halogen. Bromine's a halogen. So S is in the same group as O. S is going to be the central atom. It's written first. So you're going to write S as the central atom. And it's got 6 valence electrons. 1, 2, 3, 4, 5, and 6. Okay, bromine is a halogen. We know it's got 7. 1, 2, 3, 4, let's do this. 5, 6, and 7. And over here, 1, 2, 3, 4, 5, 6, and 7. Okay, that forms a bubble. That forms a bubble right there. Okay, so now we can just write out S, Br, and Br, and 1, 2, 3, and 4. There you go, SBr2. So that's how this works. When you do your worksheet, let me pause. Oh, here it is right here. When you do your worksheet, you're going to have some that say, it'll give you little instructions, like you'll have an ion here. The ion is hydroxide. And it says add an electron to oxygen. Well, you'll see why you're going to need to do that. Don't worry about writing in the number of valence electrons. Don't worry about that. I don't care about that. Okay, it's too much to do all of that. You know, we got to just now focus on getting these structures done. This is kind of tricky, this worksheet. There's some of them that are difficult, Okay, if you get stuck, like this one that's a tough one. H2O2 is tough. Okay, you can skip it. If you don't understand it, skip it. If it doesn't seem intuitive to you, skip it, and I'll try to solve it in class. All right, the rest of them, some of these ions are a little bit tricky as well. All right, and as always, you need to definitely for this, if you get stuck, you need to come to me and ask me for help.